String theory. What is it? To better understand the answer to that question, we have to understand why the physics world needed a theory just like this. Right now, in physics, there's a fundamental problem. Big things don't work with small things.
In quantum mechanics, or the theory that describes how small things, such as atoms and smaller particles, work, everything behaves differently than the world around us. On the other hand, gravity is part of general relativity, a theory that Albert Einstein came up with to describe how big stuff interacts, such as planets or stars, or the world around us, according to gravity. There are several inconsistencies between the two theories, such as describing black holes. But there is an even bigger issue. There are four fundamental forces in the universe, three of which are described by quantum mechanics and particle interactions. The weak force, which holds electrons and nuclei together, the electromagnetic force, which involves charged particles, the strong force, which holds the nucleus of an atom together, and the fourth force being gravity. Only gravity is not described by a particle and is not part of quantum mechanics.
If these two theories are unified, we'd have a theory of everything. This would completely revolutionize the physics world because it would fully explain and link all physical aspects of the universe, big and small. This would help in many ways. Besides having the world simplified to a few equations, it would help us understand black holes and even the beginning of our universe. Interactions that occur on a large scale, such as gravity, would be explained by interactions between particles on a subatomic scale, in this theory of everything.
So we have this glaring inconsistency in physics. The two main theories do not work together. String theory can be used to fix this problem. But what is string theory exactly, and how can it help?
String theory is an attempt at microscopically describing gravity. A string is a tiny filament of vibrating or oscillating energy that would make up everything in the universe. It would replace point-like particles such as photons, electrons, and quarks. Strings are very small. If that atom were about the size of a solar system, a string would then only be about the size of a tree.
That string vibrates or oscillates at different frequencies, like strings on a guitar. That specific frequency determines certain properties of a particle, such as mass and charge. So, an electron may be an E, while a quark may be a G, though it won't be on the tune. In the current mathematical model of string theory, it requires 11 dimensions to work. These dimensions would be curled up upon themselves and be so small we can't observe them. This is not uncommon in physics, as many theories' issues are resolved by adding dimensions. The way string theory ties general relativity and quantum mechanics together is it states that all forces are just interactions of strings oscillating at different frequencies. Strings can already describe the other three fundamental forces in nature. The particle for gravity that a string describes is called a gravitron, which is consistent with current math models of string theory. If this gravitron existed, it would explain gravity on a quantum mechanics scale, thus describing and uniting all four fundamental forces under one mathematical model. So there you have it. If we manage to complete the theory and verify it with correct predictions, we would understand how our universe works much better. But until then, we need more people like you to unravel the universe's mysteries.